244. 206. What we discussed in previous class?
Ma'am, about osmosis.
Ma?
About breakpoint chlorination, internal treatment of boiler feed water.
No.
Osmosis, ma'am.
Yes, already I shared on screen only. Okay. So reverse osmosis. First of all, what is the definition of osmosis? Osmosis and ion exchange. Okay.
Osmosis means higher concentration to lower concentration.
No. Lower concentration to higher concentration. Okay. The solvent moves lower concentration to higher concentration. Exactly opposite reverse osmosis. Exactly opposite. It's not reverse osmosis. Osmosis. Already I explained one example also. Dry grapes soaked in a container of water. The concentration of the minerals inside the grapes is higher than the concentration of the minerals in the container of the water. When we soak for a few hours, we see that the grapes swollen. Okay, you know, dry grapes. Already I said Christmas, right? Remember carefully, it is very, very important, reverse osmosis and ion exchange. That's why I repeated again. Okay, so osmosis, the dry grapes dissolves into the water. The dry grapes dissolves into the water after some time. After a few hours, the grape is swollen. Okay, so why does this happen? Why does this happen? The water from the compartment moves into the grapes. That is the skin of the grape act as a semi-permeable membrane. Okay, so the skin of the grape is act as a semi-permeable membrane. So the semi-permeable membrane acts as only, the semi-permeable membrane allows only solvent. Okay, so the solvent semi-permeable allows only solvent. Okay, so and the water moves from the lower concentration to higher concentration side. This is the natural process. This happens with the minimum pressure, which we call it as osmotic pressure. Okay, which we call it as osmotic pressure. Okay, so here reverse osmosis. The reverse osmosis contains two compartments. Okay, see the picture. This is the reverse osmosis picture. Okay, so the compartment with the upside is brackish water. Upside contains brackish water. Brackish water is nothing but salt water or sea water or saline water. Okay, so which is a higher concentration. So these water has higher concentration in the compartment. In the compartment down of the bottom of the compartment contains pure water. Okay, so these bottom of the part contains pure water, So where the lower concentration, both the compartments separated by a semi-permeable membrane. So in seawater contains seawater has higher concentration. Pure water has a lower concentration. Okay. So these two water separated by using a semi-permeable membrane. Semi-permeable membrane. What are the chemicals we used in semi-permeable membrane? Anybody? Three chemicals we used. What are those?
Cellulose acetate,
Yes,
polymethacrylate, polyamides.
polymethacrylate and polyamides. Cellulose acetate, polymethacrylate and polyamides. Very good. So seawater has, what is the concentration of seawater? Is higher concentration or lower concentration?
Higher concentration,
Pure water contains,
lower concentration.
very good. So we apply pressure. What we call that pressure name?
Osmotic pressure,
No, osmotic pressure, it is a natural pressure. Okay. So it is a hydrostatic pressure. Okay, osmotic pressure is greater than no. Hydrostatic pressure is greater than osmotic pressure. Okay. So osmotic pressure, it is a natural process. Hydrostatic pressure is some more. Okay. So apply pressure on the brackish water pressure. The water moves from the water into the pure water side of the sea water into the pure water compartment, and the water we collect out is called as RO water. Where do you observe these RO water? Water purifiers. Okay, this diagram is very important. Okay, so already you know advantages and the disadvantages also. Okay, advantages, what are those advantages? The process is simply cheap and reliable. It not only removes the ionic salts but also the non-ionic colloidal matter and high molecular weight organic matter. Okay, just it allows the solvent only. It doesn't allow the any wastages like non-toxic colloidal matter or high molecular weight of organic matter. These type of substances won't allow the pure water. Okay, so although the installation cost is high, the maintenance cost is low. First, we have to invest. Later, we have to maintenance. That maintenance cost is low only. The membrane can be replaced in 3 to 4 minutes, and hence can get uninterrupted water cycle. Okay, that those are the advantages. Limitations and disadvantages. The membrane cost is very high. Okay, so three chemicals we used in the um, semi-permeable membrane. Those chemicals are very costly. That's why it is I mean semi-permeable membrane cost is high. Okay, membrane should withstand pressure of 20 to 100 ppm. Sorry, 100 atmospheres only. Okay, it won't allow the high temperatures. 20 to 100, remember. And next topic is ion exchange. Okay, so how many compartments are present? How many towers are present in the ion exchange process? Anybody? In ion exchange process, how many towers are present?
2, ma'am.
Very good. So what is the first name? What is the first tower name?
Cation exchange resin,
Super. And second one is
anion exchange resin,
okay. And next, so ion exchange process in cation exchange resins, which elements are exchanged? What are the elements are exchanged in the cation exchanger? Cation. What is the charge of cation? Cation. Positive or negative?
Positive.
Yes. So cation exchanger exchanged by cations means positive charges means metals. Okay. Already it is visible on the screen. Okay. Sodium, potassium, calcium, magnesium. These four elements are exchanged in the cation exchange process. Okay. Anion exchange process, sulfate, chloride ions. Sulfate, chloride ions. Okay. Okay. So once I'll explain, listen careful. This is very, very important ion exchange process. So this process requires two towers or columns. The first is cation exchange column, which is packed with the cation exchange resin, which is packed with this cation exchange resin is packed with cation exchange resins capable of exchanging H plus ions. The anions exchange column, which is packed with anion exchange resin capable of OH minus ions. So these cation exchange resins is packed with cations. These anion exchange resins packed with anion resins. Okay, so what is meant by raw water? What is meant by raw water? Nothing but all the water source collected in the reservoirs means soft water or any all types of water collected in the reservoir or hard water. Okay, so these water will contains all the types of minerals in it. For these example, let us consider the raw water contains say, calcium sulfate and sodium chloride. Okay, what are the chemicals present in the hot water? Calcium sulfate and sodium carbonate, sodium chloride. Okay, so temporary hardness means what are the chemicals present in the temporary hot water? Anybody? Temporary hard water, carbonates and bicarbonates. Permanent hard water contains non-carbonates. You can say non-carbonates or sulfates and chlorides are present in the permanent hard water. Anything you can say, no problem. Okay. Temporary hard water contains carbonates. Permanent hard water contains non-carbonates. Non-carbonates are nothing but sulfates and chlorides. Okay. So when this raw water is passed through the cation exchange resin, the H plus ions present in the cation exchange resin to get exchange the calcium and sodium present in the water. Now, the water coming out this column is free from cations. When this water is passed through the anion exchange column, so anions anion exchange column, the OH minus ions present in the anion exchange resin get exchanged with the sulfate and the chloride ions present in the water. The water coming out of this column is free from both cation and anion exchange resins. Okay, so this water is called demineralized water as the minerals present in the water are removed. This is called demineralization. Okay, so deionized water as the cations and anions present in the water is removed. Deionized water. So what will happen? The H plus and OH minus ions get exchanged with the cations and anions present in the water. We call such resins. We call such resins to be exhausted. That ions for that at this stage resins can be regenerated by passing dilute HCl. So acid regenerator contains dilute HCl, alkaline regenerator contains sodium hydroxide. Okay, so when dilute HCl is passed through, present in the dilute HCl get exchanged with the cations already present in the resin. Allotropin in the anion exchanges in the OH minus ions in dilute sodium hydroxide get exchanged with the anions present in the resin. Now the resins are ready for use again. Okay, so this is about anion exchanges. Okay, so what are the advantages of cation and ion exchange? Can obtain demineralized water with hardness less than 2 pm. This method can be used for both acidic and alkaline solution. Both cations and anions can be removed in this ion exchange process. Limitations and advantages. What are those? Anyone? Disadvantages. This method is very expensive as the ion exchange resins and the installation costs are high. The efficiency of the process is reduced if the water is turbid. This method is not suitable if heavy metals are present since regeneration of resins are not possible. Okay, that's all for ion exchange process. And today's topic is polymers. Today's topic is polymers. Okay, polymers. What is the meaning of polymer? Anyone? What is the meaning of polymer? Polymer means poly. Poly means many. Mer means units. Okay. A group of small molecules combine to form a large molecule. A group of small units combined to form a large molecule that is called, yes, many units. Polymer means many units. Poly means many, mer means units. So polymer chemistry is a subdiscipline of chemistry that focuses on the chemical synthesis, structure, chemical and physical properties of polymers and macromolecule. Polymer we can call as macromolecule or large molecule also. Okay. So introduction, polymers from very important component in our daily life. The the polymers are highly useful in domestic and industrial and medical fields. The following are the reasons for the extensive use of polymers and safe to use. Okay, so they have low densities in low density means light in weight. So transportation of polymers will be is they possess good mechanical strength. They are resistant to corrosion and will not absorb moisture when exposed to atmosphere. These function these function as thermal and electrical insulator. These can be molded and fabricate easily. They possess aesthetic colors. They possess aesthetic colors. Okay. So polymers in our daily life, we observe many things. Okay. So we are simply depends on the polymers. You know, not any glasses, plastic glasses or plastic boxes or any water bottles. Simply we use mobiles, laptops. These all are made up of polymers only. Okay, only these electrical gadgets and plastic items we use in fabrications also. Okay, simply we are depends on the polymers. Okay, so it is very use in our daily life. Okay, so polymers are very important components in our daily life. Like we use plastic boxes, bottles, and cell phones, electrical gadgets. Okay, and fabrics. The polymers are might useful in domestic and industrial and medical fields also. The following the following are the reasons for the extensive use of polymers. Okay, so pickles, pickles store long life long standing pickles like lemon pickle or those pickles we have to store into the plastic containers or clay jars. Plastic containers or clay jars. Why we can't store in metal containers? Is there any reason? If you store the metal containers, what happens?
Acid in the
After
pickles
some
reacts
days,
with metal.
yes. So, and also it turns the poisonous. Okay, it turns the toxic substances. That's why we should not store into the metal containers. So we have to store into the plastic or clay jars. Okay, these plastic items where we get by using a polymers only. Most of the polymers are non-toxic and safe to use. And the medical purpose also we used, laboratory equipments, pharmaceutical industries. We use mostly high quality polymers we use. They have low densities. They have low densities means it has low in weight, light in weight. So transportation of polymers will easy. They possess good mechanical strength, and these are resistant to corrosion and will not absorb moisture when exposed to atmosphere. These can function as good thermal and electrical insulators. These can be molded and fabricate easily. They possess aesthetic colors. So it is also interesting to note that many carbohydrates, proteins, enzymes, and DNA, DNA, RNA are natural polymers. What is the full form of DNA? Anyone? DNA full form: deoxyribonucleic acid. RNA full form: ribonucleic acids are natural polymers. Polymers are can be defined as the large molecules formed by the linkage of small molecules called monomers. You know the definition very well. A group of small units are a group of monomers linked by a large molecule. Polymers can be defined as the large molecules formed by the linkage of small molecules called monomers. In Greek language, poly means many and mer means units. So this is the definition for polyethylene. Polyethylene. So N means number of, ethylene means two carbons, ene, double bond. Okay. So ethylene. Already you know the valency of carbon. Carbon, what is the valency of carbon? What is the valency of carbon? Four. Nice. So here, how many bonds, how many hydrogens are present in the carbon? Two hydrogens are present in the ethylene. Ethylene. Okay. So remaining these two bonds. En means double bond. It means two carbons. If you take any compound, that compound contains two carbons, and the compound contains double bond. We can say easily two carbons eth and double bond is ene, ethylene. Okay. So this is polymerization. After we get the after we get the
Polymer.
ethylene. Okay. Yes, polymer. Polymer. So number of polymer, number of ethylene groups are present. Okay. So thus the repeated unit of polymer is called monomer. Thus the repeated unit of polymer is called monomer. The number of repeating units in a polymer chain is called degree of polymerization. For example, if 100 molecules of ethylene polymerize to give polymer chain, the degree of polymerization is 100. So types of polymers, homo and copolymer. Homo means same type of, okay, polymer made up of only one type of monomers. Example, polyethylene and PVC. What is the full form of PVC?
Polyvinyl chloride.
PVC full form, super, polyvinyl chloride. So homopolymer means made up of only one type of monomers. Example, polyethylene and PVC. So next one is copolymer. Exactly opposite. Polymer formed by the reaction between different monomers. Example, Bona S rubber. Okay, so here you can observe Bona S rubber. Two different types of monomers present in the polymers. Homopolymers means same type of monomers present. Copolymer, different types of monomers are present. Example, Bona as rubber. Classification of polymers based on origin. Based on origin. Nature, that is plants and animals are called natural polymers. Example, starch, cellulose, proteins, natural rubber. Okay, so polymers are again divided into two types. One is based on the origin. Origin means obtained. Okay, natural polymers and synthetic polymers. Natural polymers means obtained from naturally. Okay, synthetic polymers which are prepared in the laboratory are known as synthetic polymers. Okay, natural polymers examples starch, cellulose, proteins, natural rubber. And synthetic polymers examples PVC, polyethylene, synthetic rubber, nylon 66. Polymerization. So it is the fundamental process, the low molecular weight compound converted into high molecular weight compound. That process is called polymerization. Okay, low molecular weight compound converted into high molecular weight compound. That process is called polymerization. Understand? So types of polymerization, these are three types of polymerizations. They are addition polymerization, condensation polymerization, and last one is copolymerization. Okay, so first one is addition polymerization. Okay, so addition polymerization is the another name, chain polymerization. Addition of polymers are formed by adding of monomer units without any loss of atoms or groups. These polymers formed by the polymerization of monomers containing double or triple bonds. Double or triple bonds means nothing but unsaturated compounds. Okay, first these are reactants and these are products. So in reactant we can take a double bond or triple bond, but we get the single bonds. Okay, so in this mechanism we didn't get any loss of functional groups or any small molecules we does not loss. Okay, so ethene, so number of ethene groups are reacted to form the polythene. Okay, so this is a chain polymerization. Okay, so it is a chain linkage. And next one is vinyl chloride. Vinyl chloride, CH2 double bond CHCl. The chemical name is vinyl chloride. Okay, so after polymerization we get the polyvinyl chloride, CH2 single bond CHCl. So like this we have to draw CH2 like this, CH2 CHCl like this we can. It is called as polyvinyl chloride. And next one is condensation polymerization. Next one is condensation polymerization. Polymers formed from the functional groups of monomer with the elimination of byproduct and with the formation of new functional group are known as condensation polymers. Condensation polymers. Okay. So polymers are formed by the functional group of monomers with the elimination of byproducts. So here we have to eliminate. So you can observe this is the adipic acid. Adipic acid CH2 4 COH N. Adipic acid. So CH2 bond CH2 bond CH2 bond like this CH2 we have to write 4 times. Okay, at the both ends contains COOH groups. Okay, so this chemical name is adipic acid. Next, hexamethylene diamine. Hexamethylene diamine. So here hexa means 6. Hexamethylene. Meth means only one carbon. Diamine. Two amine groups are present. Hexamethylene diamine. Okay. So reacted to forms the nylon 6,6. Okay. So here you can observe COOH. So but here we can remove the OH group and here OH groups also removed. So and here 2 hydrogens are removed. Here 2 OH, one here OH. So adipic acid contains 2 OH, right? So end of the 2 ends of the compound. Similarly, hexamethylene diamine. Amine group contains 2 hydrogens. In that 2 hydrogens are removed. 2 OH and 2 hydrogens to forms the number of water molecules are released. So this is the nylon 6,6 structure. C double bond CH2 4 C double bond NH CH2 6 NH. Okay, so this is nylon fabric and nylon plastics and nylon rolls. These are the examples for nylon fabric, nylon plastic, and these are nylon rolls. So next one is terling. And next one is terling. So ethylene glycol. Ethylene glycol. You can observe the formula. Remember, formulas are very, very important. Practice that. Okay. So ethylene glycol. Okay. So OH CH2 CH2OH CH2OH. You can write CH2OH CH2OH. So but this CH2 we have to connect the one bond. Okay. So plus ethylene glycol react with terephthalic acid. Terephthalic acid. Benzene contains 2 SD groups, COOH groups reacted to forms the decron. To forms the decron. Okay. So what is the byproduct here? Water molecule. Okay. So here OH group and this OH group. And here hydrogen and here hydrogen, 2 hydrogens and 2 OH minus molecules converted into a water molecule, and we get the decron compound, decron polymer. And next one is copolymerization. Next one is copolymerization. The polymers which are obtained by the polymerization of 2 or more monomers are called copolymers. This process is called copolymerization. This process is called copolymerization. Okay, so we get the more monomers. Okay, so you can observe butadiene. Butadiene. Buta means 4 carbons. Buta means 4 carbons. Butadiene. So here you can observe ene means double bond. CH2 double bond CH single bond CH double bond CH2. This is the formula of buta. This is the structure of butadiene. So reacted styrene formula CH double bond CH. Okay. So reacted to forms the Buna S. Buna S. CH2 CH double bond CH CH2 CH2. Buna S. This is the structure for Buna S. Very, very important, students. Remember and practice the formulas. Then only you get. So differences: addition chain polymerization and condensation step polymerization. Okay. So tomorrow I will explain these differences. So give me your attendance.
Thank you, sir.